lesson, they've got the division of a polynomial, 3x cubed minus 7x minus 9 by x minus 2, and they've got the work in here. So some of the things to remember, we make sure that we have each term represented. So because I didn't have an x squared, I have to put it in as a 0x squared. And then it's 3x cubed divided by x gives me 3x squared. Multiply 3x squared by my binomial and subtract. Carry the negative 7x down, and then I start the process over. So I get this 3x cubed minus 7x minus 9 is equal to x minus 2 times this quotient plus the remainder. So there's a student that is repeating the course, so they've already gone through everything, and they show their buddy that there's a quicker method. So in this quicker method, this is what we have. We have 3, 0, negative 7, negative 9, and then 2. And then I've got these numbers down on the bottom. So let's start off by figuring out where does the 3, 0, and negative 7 and negative 9 come from? Where do these three numbers come from? Where do I see those three numbers?
From your equation, like the polynomial then?
They're the coefficients from that polynomial. Okay? So that's question 2. So they're the coefficients and constant term. Where does the 2 come from? The 2 that's on the left side, where does that come from?
Is that from the x minus 2?
That's from the x minus 2. Specifically, how could I use that x minus 2 to get that 2? Is it just the constant, or could it be more?
Is it like the, it's what you're dividing by?
Kind of. It's the 0 of the factor x minus 2. If I let x minus 2 equal 0, what does x equal? 2. That's why it's a 2 and not a negative 2. Right? So these numbers here were exactly what I had written here, whereas the 2 is the opposite sign. So it's not just taking away the x. It's if I let x minus 2 equal 0, solve, I get x equals 2. Okay? So now if I look at the next part of it, the circling of the 1. What does this represent? That was my remainder. Okay? Really? Okay? Where did the 3 come from? There's the arrow. So the 3 dropped down. How do I get the 6?
2 times 3.
Pardon?
The 2 times 3.
2 times 3. Okay. How would I get this 6?
It drops down.
It drops down.
And then 6 times 2 is 12.
Okay, so how come this
it'd be
isn't
like
12?
0 minus 6.
Okay, 0 minus 6. So if this is 0 minus 6, this should be negative 7 minus 12. Does that equal 5? Probably not. Negative 7 minus 12? That equals negative 19. So how could I use the negative 7 and the 12 to get to 5? I can add them. Does that work for my 0 and 6? Does that work for my negative 9 and 10? So I multiply, and then I add. I multiply, and then I add. I multiply, and then I add. Okay? So the 3, the 6, and the 5, where do we see those numbers in this statement?
And the quotient.
They're the quotient. It's what part of the quotient?
Oh,
The
coefficient and the constant.
Right. So it's the coefficient and constant in the quotient. I should put that part in there. Because that's the important part, is it's the part in the quotient. And can you identify how the sets of numbers 6, 12, 10, can you identify how 6, 12, 10, and 3, 6, 5, and 1 are obtained? We did answer that question. So I can get the 6 was the 2 times 3. The 12 was the 2 times 6. The 10 was the 2 times 5. And then the 3, 6, 5, and 1 I got by adding those columns. Okay? I'm not sure how you want to put that in there, other than just writing down 2 times 3 is 6, 2 times 6 was 12, 2 times 5 was 10. And then 3, I got that by just carrying the 3 down. I got the 6 by going 0 plus 6. We got the 5 by going negative 7 plus 12. And we got the 1 by going negative 9 plus 10. So synthetic division takes out my variables. That's what happens when we look at synthetic division. So if we look at this, complete the following synthetic division to determine the quotient and the remainder when 2x cubed minus 3x squared minus 8x plus 15 is divided by x minus 1. So I've solved, or I've determined my 0 for x minus 1 is 1. And then I've placed my coefficients in this top row, keeping the signs in front, so this becomes a negative 3, negative 8. I always start off the same way. Drop the first. And then it's the same process. What do I do with the 1 and the 2? And where do I put that?
Under the negative 3.
Okay, and then what do I do with the negative 3 and 2?
Half them.
And then, and then,
Half them.
and then, okay, and then add, and what do I get for my final
6.
6? Okay. Now, if you remember from the previous question, this bottom row gave me my quotient and it gave me my remainder. So which one of those 4 is the remainder?
6.
The 6. So we circle it. Circle it, that reminds me it's the remainder. Okay? The other thing that we talked about yesterday is that my quotient, the degree of my quotient, can't be more than the degree that I started off with. And most of the time it's usually 1 less. The way that I always look at it, if this is the remainder, this is the constant. And then I just go up from there. So I have the constant, and then I'm going to have an x, and then this one would be a 2x squared. That was a negative x. that becomes my quotient. Plus the remainder, which was 6, divided by the divisor. And I'm not going to write the P over D. Okay, so class example number 2, we're going to start this right from scratch. I have 5x to the power of 5 minus 6x to the power of 4 plus 3x squared minus 2x plus 1. We're going to use synthetic division to determine what the remainder is when I divide this by x plus 2. So when I set up my synthetic division, I have basically, it kind of looks like two sides of a rectangle. Inside go my coefficients from my polynomial. Make sure your polynomial is written in descending order. And do I have all of my terms listed? 5, 4, what am I missing? 3. So what do I need to put? I've got 5, negative 6, then I need the 0. 3, negative 2, and 1. What goes to the left of my rectangle?
The 0 of the divisor.
Okay. So what would it be? Negative 2. And then I drop down the 5. And then it's the multiplying and the adding. So I'll give you a moment to multiply and to add. So when I go negative 2 times 5, I get
Negative 10.
and then when I add it to the negative 6,
Negative 16.
multiply by negative 2,
32.
add,
32.
multiply,
Negative 64.
add,
Negative 61.
multiply,
122.
add,
120.
multiply,
Negative 240.
add.
Negative 239.
So what's my remainder?
Negative 239.
Okay? And then my quotient, what would my quotient be? So if 120 is my constant, then I have x squared, x cubed, x to the power of 4. So I'd have 5x to the power of 4 minus 16x cubed plus 32x squared minus 61x plus 120. And then my remainder would be negative 239. Okay, so repeat the process, only this time, or sorry, it says find the value of the polynomial when the value of x is replaced with negative 2. So 5 times negative 2 to the power of 5 minus 6 times negative 2 to the power of 4 plus 3 times negative 2 squared minus 2 times negative 2 plus 1. So what is negative 2 to the power of 5?
Negative 32.
And when I multiply that by 5,
Negative 160.
okay? Negative 2 to the power of 4.
Negative 16.
Positive 16.
Positive
Because the
16.
brackets, right? So 2 and 2 is going to be a positive, then a negative, then a positive. So positive 16 times negative 6. 2 squared? 4. 4 times 3?
12.
Negative 2 times negative 2?
4.
So if I take negative 160 minus 96 plus 12 plus 4 plus 1, what do I get?
Negative 239.
Where have we seen that number before?
Oh, what's your constant?
It's not my constant, it's my remainder. So the remainder is equal to the value when x is equal to negative 2. Okay, class example number 3. Do some working backwards. If x plus 3 is the divisor in the following synthetic division, calculate the values of m and p. So if x plus 3 is the divisor, what am I putting to the left of my synthetic division?
Negative 3.
So then I carry that 2 down, negative 3 times 2, negative 6 plus 2, negative 4 times 3. So what do I have written right here? I have that negative m plus 12 equals 2m. How do I solve that equation? Move m to the other side, so now I get 12 equals what? And what does m equal? 4. So instead of 2m, now what would I have? Not 4. 2m would be 2 times 4. So this would be 8. So now when I take the 8 and I multiply it by negative 3, what do I get? So n is now negative 24. And what is 16 plus negative 24? Negative 8. So then p is negative 8. Okay? Next type of example. When 2x cubed minus 4x squared plus ax plus 3 is divided by x plus 2, the remainder is 3. Find the value of a. So we can do this using synthetic division. We set up our rectangle. What goes to the left of my rectangle?
Negative 2.
Negative 2. Why is it negative 2?
So that's the 0 of that equation.
Good, that's the 0 of the divisor. So what goes along the top inside my rectangle?
2, negative 4, a, and 3.
Okay. And what else can I put in here?
You put your 3 with the remainder under the 3.
If I can put my 3 in, I'll circle it because it is my remainder. Okay. 2 times negative 2. Negative 4. Negative 4 plus negative 4. And negative 2 times negative 8. So then what do I get right here?
8 plus 16.
Yes. And then when I multiply it by negative 2, what do I get?
Negative 2, 8 minus 32.
Negative 2 minus, what did you say?
Minus 32.
when I add these two together, 3 plus negative 2a minus 32, what am I supposed to get? 3. So I've got negative 2a minus 29 equals 3. Add 29 to each side, and negative 2a would equal,
32.
and what does a equal? Does that make sense? If I go back and check this, negative 8 times, sorry, if this was negative 16 plus 16 would equal 0. Negative 2 times 0 would equal, and 3 plus 0 would equal 3. Or I could work backwards. When I got to this point here, I could have worked backwards. In order for this to work, to get my remainder of 3, this would have had to have been 0. And the only way that I'm going to get 0 is if whatever's down here is equal to 0. And then I could have solved a plus 16 has to be equal to 0. So then a equals negative 16. Okay? The last example just takes this up one more step and says, what happens if your divisor looks something like this, like a 2x minus 1? Does that change what we do for synthetic division? Is that still recording, Jessica?
Yeah.
Okay. I think it's almost done, so I'm going to stop it and start again. So the answer is it does not change how we do the synthetic division. I can still use the same process. I let 2x minus 1 equal 0, and I find the 0 of that. So I move the 1 over, divide it by 2, and I get 1/2. They do something really, they start getting confusing over there. So this is my 0. That goes along the outside. My coefficients and constants still go along the top. And it's still the same thing that I was doing before. I'm still carrying this down. 2 times 1/2 is 1. 1 plus 1 is 2 times 1/2 is 1 plus 5 is 6 times 1/2 is, and negative 1 plus 3. So this becomes my remainder. So now when I go and I look at this, I have this statement right here. My divisor, it's not the 2x minus 1 anymore. I'm going to leave my divisor as an x minus 1/2. Then I've got my quotient, and then I've got my remainder. If you notice, I can divide everything in my quotient by 2. So I divide everything by 2, and now I'm left with x squared plus x plus 3. And this part right here, when I multiply the 2 by the x minus 1/2, I get back to my 2x minus 1 that I started off with. And then I still have the x squared plus x plus 3 and the 2. So the remainder does not change, but the quotient does undergo a little bit of simplification. So we do have to kind of think of both sides. I took out a 1/2, or it's the same as I divided by a 2, but all of this was divided by 2. So my equation will still balance in the end. So quotient is x squared plus x plus 3. So we're going to do another example. So I have x cubed, x squared, x, and a constant, so I don't have to worry about putting in any zeros. I can write out the coefficients. And then my 3x plus 2. What would x equal? So that's what goes along the outside. Drop down by 6. If I have to take 6 and multiply it by negative 2/3, and I didn't want to use my calculator for it, how can I do that? 6 divided by 3 times negative 2, negative 4. Add those two numbers together and I get negative 12. So when I take negative 12 and multiply it by 2/3, negative 12 divided by 3, multiplied by negative 2, it'd be positive 8, because I get a negative 4 when I divide it. When I add them together, 3. And when I take 3 and I multiply it by 2/3, I would get negative 2. 3 divided by 3 would be 1 times negative 2. And then 5 plus negative 2 would be 3. So my remainder is 3. My quotient is 6x squared minus 12x plus 3. Can I factor something out of that? A 3. Oops. And when I factor out a 3, I'm left with 2x squared minus 4x plus 1. So if I write this out, my 6x cubed minus 8x squared minus 5x plus 5 equals the divisor, which my divisor is my x minus 2/3 right now. And then my quotient was all of this. 3 times 2x squared minus 4x plus 1 plus my remainder of 3. And then the last step that I would do is I would take this 3 and I would multiply it by my x minus 2/3. 3 times x would give me 3x. And what's 3 times negative 2/3? Negative 2. And then 2x squared minus 4x plus 1 plus 2. So now I'm at the divisor. Wait a minute.
Shouldn't it have been x plus 2?
Yeah, it should have been x. Oh, x plus 2/3. That was my mistake right there. Because my 0 was negative 2/3. So if my 0 was negative 2/3, I could write this as an x plus 2/3. Sorry, that was my mistake. Okay. The purpose behind synthetic division is because what we get into is we get into factoring polynomial functions. So in order to factor polynomial functions, you're going to have to find a factor, something that divides evenly into my polynomial. And synthetic division just helps you do that process a lot faster and in a lot less space. Because if I would have had to do this using the long division, I would have needed a lot of space to put that in. So that's the purpose behind why we're doing the synthetic division, is because we want to be able to factor polynomials that are x to the power of 3 and x to the power of 4. And factoring those polynomials then allows me to sketch the polynomial. I can kind of tell you what the shape is going to be based on certain characteristics. So questions 1, 2, B, and D